Hello. So today I'll be presenting LLM Logger, a full stack observability platform I have built for monitoring and analyzing the LLM inference in the real time. So the problem is actually trying to solve a straightforward. Okay. So when you are actually building the AI powered application, it is often, it is difficult to understand what is happening under the hood. So you send a message, you receive a response, but you have a very little visibility into performance, the reliability, the amount of token it has used, the latency, or the failures. So the LLM, so this project, this LLM logger gives a developer that visibility. Okay. So, so you to the right, you can see and select the model which you want of your choice. That is GPT-4, Claude, Gemini, Llama, or DeepSeek, any of them. Okay. So all the requests are routed through the Puter.js, so the developer can actually experiment with the multiple models without managing the API keys. So from the user perspective, it is just a seamless chat experiences. So let's just go with this. Okay. Okay. So now behind the scenes, every inference request is automatically captured and logged. So for each request, we record the metadata such as आपकी latency, आपका amount of token it has been used, the model information, your request ID, and sanitized previews of both the prompts as well as your responses as well. So if I switch to log sections, so you can actually see every inference event is stored in the system. So developers can actually filter this with the filters this log by model, the status, or you can search it directly through the if request through the request content as well. Okay, so making the debugging and monitoring significantly easier. Okay, so let's just search this. Okay, by GPT-4. If I try to do it by C, yeah. Okay, all models success. There's nothing. Okay, if I want to search this by the request, okay, give it. So next is our dashboard. So this actually tries to assimilate all the inference data into the real-time metrics, including the total amount of requests, आपकी success rate, and आपकी latency, and amount of token that has been consumed, and the historical trends that has been displayed through the time series visualization. So instead of inspecting individual requests, developers can, he she can quickly understand the overall health and the performance of the AI application as well. Okay. Hmm. So let's just talk about the architecture. So the front end is actually been built with the React and Redux toolkit. So whenever a user actually sends a message or creates a conversation, okay, so the UI will update instantly without actually waiting for the backend. So data is then you synced it to the server in the background. So making the application feel fast as well as the responsive. Okay. Hmm. And on the back end, I have built an Express API with MongoDB acting as an ingestion pipeline. So the incoming logs are actually validated by using Zord before it has been stored. Okay. And indexing strategies are also been used to keep filtering, searching, and dashboard aggregation performance as the data grows. Okay. Fetching the data. Hello, hi. How can I assist you today? Hmm. So these are actually our APIs. Okay. Hmm. Also, one more thing I like to say. So the platform also includes the redaction, sensitive information PI redaction. So the sensitive information such as email addresses, your phone numbers, your payment card numbers, SSN numbers, these are automatically been scrubbed, or I can say these have been masked. These have been masked from store previews before it is reaching to the databases as well. So this will help the organizations to maintain the observability without unnecessarily storing your sensitive user data. Let me show you once. Okay, so this is actually the pirate. I Let's take one example. Hi, my email. Let's take a random email. Okay, email is okay. AY at the rate your Gmail. Okay. Hmm. This is it. See, this is what I was talking about. This is actually the pirate actions. Okay. Let us. Right now we have zero errors, but this graph works as well. Okay. Mm, yeah. Just now we have created this. Now let's try out some other models as well. Let's go with DeepSeek. Yeah. I see if I turn this off, if I turn it off, then if you do this like my email is so and so my email, then it will not hide it at all. Hmm. You have to toggle it for this functionality to be working. Okay. You can also see the amount of token that has been consumed, the average latency time period, the success rate. Till now it is 100%. Let's just try out. Okay. Let's try this Grok. Okay. So yeah. Hey, it's gonna work. See. So this will reflect over here. Here. See. The current time is 9 1919, which is 7:19 evening. So errors over that time. One error. And I have made actually two requests at this particular time period, so it is reflecting in a real time, as you can see over here. So these are actually the model breakdowns where you can actually see a split between the GPTs, Grok, uh, DeepSeek Claude model. So maximum times I have been using the GPT 4o mini. Okay, so currently I actually made use of this Grok. Okay. See, if I turn this off, then the pi reduction enable, this will show me false because this is a Boolean value. Let's check once. Hey, whatever it may be. Okay, give some time. So let's just refresh us. Yeah, there you go. So, uh, so finally, so user preferences such as आपको selected models, streaming configuration, and the privacy settings. These are actually been persisted in the MongoDB, which is ensuring consistent experience across the sessions. So overall, the LLM Logger is like a practical developer tool that actually brings the visibility, your monitoring, analytics, and privacy control to LLM powered applications through a clean, I can say, the separation between the front end experience, the logging pipelines, and the analytical layers as well. So, thank you. Thank you for your time.